The computer program did is something like this. Let's assume that there's a spinner that gives you winnings at 40%. Okay, so 40% of the spinner is win, the others lose. And you do this 1,000 times. Okay? And you count how many wins you got. Okay? Then with 99% probability, the wins that you're going to get will be between 370 to 430. Okay? Now this becomes even more interesting if you were to think about this hypothetical situation where, let me see. So think about the following: you generate you get what do you call it? A weighted dice. That's like you tilt it, you fix it so that it gives you more, say, number sixes than any other number. Okay, and then you sneak that into a casino, and then you somehow play with it. Okay, you start winning big, and then they catch you, right? And then they take your dice, and what would they do? They would use a machine to throw the dice. How many times? Like maybe 10,000 times. Right? Now, or maybe let's say they did 6,000 times. Okay? And then if out of the 6,000 times, if your dice rolled number 6, say more than 1,000, say 2,000 times, yeah, then you would start questioning, is this really outrageous, or is it possible? I mean, you might be able to argue that it's all probability, so like maybe we just got lucky. You got 6 more than... What's the expected number of 6s if it was a fair dice? 1,000, right? 1/6 of 6,000. So the thing is, if you were doing 6,000 trials of a probability that came with 1/6, right? That would be similar to normal distribution of this times this, which is 1,000. And then 1,000 times 5,000 over 6, and then square root. Can somebody do this for me? Actually, I'll need some people who are ready to calculate everything I write to help me out. What do you get?
28.87.
28.87? Right. So it's called the 3 sigma rule. 3 sigma rule, which is that if you have a bell curve, then here's mu plus 3 sigma, here's mu minus 3 sigma, and if you do this integral with that function that I deleted it, but if you do the integral, this will come out as 99.7%. So just getting 1,030 would be somewhere here, which is, see, this is 99.7%, which means this and this area, these two areas add up for 0.3%. So like getting over here would be 0.15%, just to get something like 1,030. So anything above this would be pretty outrageous. That's what we get. Then this one, that's like illegal. It's definitely not fair. Okay, so like if they see this, then they're gonna say, obviously you're working with the illegal dice, so you'll be thrown in jail or something. Or, I don't know, maybe they'll use some gangsters to hit you first. Okay, but anyways, that's the power of, I meant to say, that's the power of the central limit theorem. The central limit theorem says that if you do something repeatedly, then it will look like a bell curve. And that explains why in nature you see so much of this bell curve. Like for example, if you take all the height of adult males between 20 years to say 50 years, then the height will show a bell curve. why is that? Well, think of it this way, like your mom cooks broccolis and you hate it, so you say, no, I'm not going to eat it, right? And that is going to give you malnutrition, and then what could have been 0.1 inches taller, you wouldn't get that 0.1 inches, right? Or maybe somebody bought you a nice meal and you ate more, right? Or maybe you did some exercise which made your height grow or something. Or maybe it's all genetics, who knows. But anyways, what I'm trying to say is that height of the adult will be increment of many different probabilities. Sometimes your cell will divide and you'll be taller. Another day your cell won't divide. You'll be just stuck there. And all these add up, and eventually you get this height, right? Or another way to see it is like there are many genes that govern the height, right? And maybe all these come with the probability of like 1/2 or 0.3 or something. So if you have all the right genes, then you'll be really tall. If you all have all the, not to say that I'm demeaning people who are short. I'm short, so that's okay. I can make fun of short people, but I'm short. Right? But anyways, if your genetic lottery was not so good and you didn't get the good genes, then you don't get to be tall. So you know what I'm saying, right? So at the end of the day, the outcome, because this is a combination of a bunch of these probabilistic things, you end up with a bell curve. Right? And that's like the basis of statistics. The whole field of statistics wouldn't have been born if we didn't have the central limit theorem. It all depends on the central limit theorem. So many things just appear to be the bell curve because of the central limit theorem. Did I make my point?